All right, there we go. Now we're cooking. All right, so chapter 1 really is just an introduction into kind of what to expect. What are we doing? What is this wonderful topic called anatomy and physiology? Now, as we are going through all of the chapters, we are going to be practicing and using a lot of your medical terminology. This is a great opportunity for us to practice that med term, start using it, start building words, and really getting in and doing that practice. So what exactly is anatomy and physiology? Well, anatomy is the structure. Physiology is how does it work? And so when we are going through all of these chapters, that's kind of the basis behind how we're going to be covering it. We'll be covering the structure. What are the components? What are the parts that make it work? And then we'll be going over the physiology. How do those parts come together to perform some sort of task? So the components of an animal's body and our body, because honestly, anatomically, we're no different than dogs and cats. We have all of the same organs. All of the organs function exactly the same way. So the components that are making us up, helping us work, going from the smallest, we have our cells. We have all different kinds of cells, and these cells may have different looks based on their function. We have white blood cells. I don't think you guys have gotten to your colors yet. What are you doing in medical terminology right now?
Suffixes.
You're doing suffixes. Fabulous. Somebody tell me the suffix that means cell. Nice. Site. So we have skin cells and kidney cells and liver cells and white blood cells. The term for white is leuco. If I have leuco is the term for white, what would be a white cell? A leukocyte. I've also got red blood cells. The term for red is erythro. Tell me what a red blood cell would be. An erythrocyte. I've got cells that help me clot. Those are known as platelets. The medical term for platelets is thrombo. Thrombocytes. All of these cells, luckily, know how to do their job. And they are what we call differentiated. Now that's just a fancy word for saying a kidney cell is always going to function as a kidney cell. And a liver cell is always going to function as a liver cell. Because if it stops functioning as a liver cell, or it stops functioning as a kidney cell, now we're in a little bit of trouble. You do have some cells that go rogue, right? You might have a liver cell that's like, forget you, Mom and Dad, I don't want to go into the family business. And he stops, and he goes rogue. And then all these other liver cells are looking at him like, I didn't even know that was an option. I don't want to be a liver cell either. What have I just described? Yep, we're going to have liver failure. Bam! Cancer. That's what cancer is when these little cells go rogue and decide to stop doing what they wanted, what they're supposed to do. These cells come together and they form tissues. Some of the tissues, as I said, you've got kidneys, liver, you got epithelial tissue, which makes up pretty much all of you. You can see some of my beautiful epithelial tissue. I've got some on display for you right now. This is my epithelial tissue. These tissues come together and make up organs. Again, kidneys. Kidneys are the filtration system and the orders of your body. The medical term for kidney, I don't think you guys have done your organs yet. Nephro or renal. You've got your digestive system, your small intestines, your large intestines, your stomach, gastro. And don't be frantically writing down these midterms, just so you've heard them. when Ms. Rivera starts going into them, you'll be like, oh yeah, Ms. Huff said that one earlier. You've got gastro, which is your stomach. Oh, suffix. Here's a good suffix. Tell me the suffix for inflammation. So if I have inflammation of my stomach, I have gastritis. Intestines. Entero. I have inflammation of my intestines. Enteritis. Let's make our $5 word, shall we, guys? What if I have inflammation of my stomach and intestines? I've got see, look, a lot of this medical terminology, guys, you already know. You just don't know that you know. Yeah, we have gastroenteritis. Very nice. These specific organs come together and they make up your systems. Your digestive system, your urinary system, your reproductive system, etc., etc. So why do we force you to sit here in this 16-week course of anatomy and physiology? Well, number one, I love it, so I would make you do it regardless. But number two, it's your job as an LVT to understand the norms. Right? You have to know what is normal for the animal so that you are able to identify and decipher abnormal for the animal. If you don't know what normal anatomical function is, there's no way for you to be able to identify abnormal. So that's why it's really important for you to be able to have this foundational understanding. We've got to be able to differentiate what is normal, because if you can't figure out normal, you won't be able to figure out abnormal, and that's kind of the whole point behind veterinary medicine. We have a couple of, I'm going to minimize this chat, guys. So if you guys have any questions in TV land, just unmute yourselves because this chat's kind of covering up a lot of the area on my end. We have microscopic anatomy. All right, you guys have already done your prefixes. Somebody tell me, what is the prefix micro? Small. If I have an instrument that is used to look at small, tiny things, a micro what? Scope. Microscope. So our microanatomy is the anatomy that you cannot see with your naked eye. This is the cellular components for our anatomy. Macro, meaning large, is also referred to as gross anatomy. Now this is not, oh my God, that's so gross. Gross anatomy simply refers to the anatomy you can visualize without aid, right? If I pluck out a kidney and I hand that kidney to you, the macroscopic anatomy would be the anatomy that you can see without aid. Regional anatomy is just that. It's going to be individual regions of the body. And then systemic is how do these regions work overall. So if you think about regional versus systemic, we live, honestly, if you travel anywhere and someone asks you where you're from, what do you say?
Texas.
We usually say either Texas or what city are you from? Houston. Houston is systemic. However, don't we have different regions? You've got Jersey Village, Ailey, Friendswood, Alvin. Those are the regions. Houston is the system. Does that make sense? So you guys are furiously writing. Give you guys a minute. What is the prefix that means without? And or a. What is the suffix that means, actually it might be a root. I don't think you guys have done it yet. Pain. Does anyone know what the medical term is?
Algia.
Algia. So if I'm going to take an Advil to make myself without pain, what is that now medication in medical terminology without pain?
Algia.
Analgesic
Oh,
or analgesia. ic is the suffix that means pertaining to. So analgesic means something pertaining to without pain. There you go.
I've seen that word too, and I didn't never know what it meant.
Yeah,
They give it to you instead of like numbing you sometimes.
yeah. Any kind of anesthetic, anything like that, analgesic is just giving you without pain. So any kind of anesthesia. Oh my gosh, anesthesia. That's another word that we know. Oh, you need to cover your nose, sweetheart, please. Thank you. Anesthesia. Right? You go to the hospital, you're going to have surgery, they give you anesthesia. And we already know is without. Aesthesia. Without sensation. Huzzah. See, you guys already know a lot of this medical terminology, you just didn't know why you knew.
My favorite is emesis.
Emesis? What does emesis mean?
Vomit.
To vomit. All right, I'll give you guys another minute, then we're gonna move on. How did your behavior test go on Friday?
Good.
You guys did okay?
Yep.
Fabulous. Excellent. That's good. That is good. These are the main body systems. I'm going to give you just a handshake. How do you do to each of these? So we have the skeletal system. The medical term for bones is osteo. Osteo. Like I personally have a condition called osteoarthritis. Tell me what condition I have. Bones and arthro. Joints. I have chronic inflammation of my bones and my joints. Osteoarthritis. We're going to learn all the different bones. We're going to be able to identify them, location, which ones are at most risk for trauma. Integumentary. This is a super fancy word for meaning your skin. This is going to be all of the different layers of your skin. Right? We don't have just a layer that you can see. We have multiple layers, and they grow from the inside.
Most of what she says you don't even need to write down. And the PowerPoint is on her website.
Yeah, sorry guys, my internet went bloop. So
Yeah. You just don't like us.
Untrue. All right, and yes, as I was just hearing someone, you can find this PowerPoint. It is on my website. I will get it uploaded. I'm working on the Moodle. So it takes an awful lot to get that thing set up, but I will get it set up this week for you guys. But in the meantime, you can find all of this on my website. All right, let's try this again. All right. So as your epithelial cells, again, you don't have to be furiously writing all of this down. I'm just giving you a handshake, how do you do introduction. So as your epithelial cells are becoming more and more exterior, they're getting flatter and flatter, they're getting thinner and thinner until eventually they just come off. Right? We're shedding cells at just an astonishing rate. I think it's something like we shed 2 pounds, 2 lbs of skin cells every year. all of the dust in your house is epithelial cells. Here, I'll give you a little bit. Everybody gets themselves a little bit of huff right now. There's a little sprinkle of huff for everybody. The integumentary is also going to include all of the accessories, like your nails, your claws, your horns, your antlers, your hooves. The nervous system. Oh my God, I love the nervous system. This is kind of what we were just talking about last week. The nervous system refers to your brain, your spinal cord, and all of the nerves that take messages to and from your body. You have the central nervous system, which is exactly what it sounds like, located central, your brain and your spinal cord. And you have your peripheral, right? Your peripheral vision is out here on the sides. Peripheral refers to all of the things that come off of your spinal cord and innervate or provide nerve function to all the parts of your body. Your body sends messages to your brain in the way of sensory, for your brain to interpret, and your brain sends messages to your body by way of motor, to move. We're going to talk very specifically about how do these nerves work? How are they moving this electricity? It's very similar to when I plug, if this plug here is my brain, and I've got my spinal cord now taking a message from that brain to this plug. And now I've got all these additional plugs feeding off of that. These are all of my peripheral nervous system, all causing an electrical conduction to different parts of my computer. That's exactly how your body works. We are just electrical energy. Oh, the cardiovascular system. I have a special place in my heart for this one. I'll stop now. Cardio, heart, vascular, blood vessels. I really do have a special place in my heart for, I don't think I've mentioned this to you guys before. I am a member of a committee called the IACUC, IACUC, Institutional Animal Care and Use Committee. Any facility that uses animals in any capacity has to have an IACUC committee. And it is this committee that oversees the use of those animals. When we usually have animals here on campus, we have an IACUC. Because we are using animals. We are actually labeled and governed as a laboratory facility with the USDA. The definition of a lab facility is any facility that utilizes animals in any educational capacity, which is exactly what we do. I am a member not only here at the Vet Tech Institute, but also at the Texas Heart Institute. So if you are a researcher, and you want to figure out a new surgical procedure or try out a brand new surgical technique or try out a new surgical piece of equipment, you're like, okay, well, this is the number of animals that I need to use to validate my results. You first have to bring we don't call them experiments anymore, okay, that's faux pas. We do not experiment on animals, we perform protocols. It's just vernacular. So we no longer say animal experimentation, we perform protocols. So you have to bring your protocol to my committee. We meet once a month. We have to go through, it's usually a 15 to 17 page document for every protocol. We have to pour through the entire protocol and we get to decide, is this valid? Is the number of animals you're asking for appropriate? Is it research that is going to move forward the health of humankind? Is it something that's been done before unsuccessfully? So we have to go through, and you are not allowed to do anything until we say you're okay. And we're allowed to tell you to amend it. We are allowed to tell you no. But our committee is the one that has to make the final decision. So it's really a very, very big responsibility, because ultimately, these animals' lives are literally in our hands. We are making the decision whether or not to sacrifice them for the betterment of medicine. Because unfortunately, none of these protocols, none of them are live protocols. Eventually, at some point, it's a sacrifice. But what it also means is I am privy to all of the brand new research. Unfortunately, I am under a gag order. I'm under an ND non-disclosure for the majority of it. But there is some remarkable stuff being done right now, guys. Holy smokes, are you guys getting into animal medicine at an exciting time? Holy smokes. Anybody who has the desire to go into laboratory animal research, that sort of thing, you know that every hospital in the medical center has an animal research lab on site, right? Yeah. So if you go to St. Luke's, which is affiliated with Texas Heart Institute, down in the basement, so you're up, you know, hopefully you're not sick. Maybe you're just visiting someone. Hopefully they're not sick. I don't wish any sickness on anybody, because that stuff will come back to you. But if you go to the hospital, down in the basement, there are cows.
Really? Cows?
Yeah, cows, sheep, goats. Sometimes they use pigs.
Considered that they might be using farm animals in there. I just thought it was rats.
No, not just rats and mice, although they do have rats and mice, and they also have rabbits, obviously. They have a very specialized rabbit colony that is here in Houston, is the only colony of its kind in the entire country. They're called the Watanabe rabbits, and they're born with a genetic abnormality that causes plaque to build up in their arteries. And so we're able to try out different types of cholesterol medications to help reduce the plaque. Cows, we use those because one of the experiments that I can talk about that does get me really excited about all things anatomy related. See, I'm not too far off topic. They're doing something right now, and it's a really interesting TED Talk. It's by a company called Bivacor. It's called the Total Heart Replacement. And basically what they've done is they have created a device where they just take out the whole heart, the whole biological heart, and they implant this machine. And the machine takes over oxygenating your blood, because ultimately that's what the heart is meant to do, is to move oxygenated and deoxygenated blood through your body. Without it, you die. This Bivacor Total Heart Replacement, why it's so exciting is because it's self-regulating. In the past, you would have a heart, total heart, but you'd have all these wires, and they would be attached to a battery pack. And if you needed your heart to speed up, you would have to manually do it. So like when you walk up the stairs, what happens to your heart rate? It speeds up because your need for oxygen has increased. You would have to turn the dial and do that manually. This Bivacor tracks all of that, and it is self-adjusting, and it will speed up and slow down automatically, which is huge.
How well are the trials going?
They're going really well. We did our first trial. That's why it's gone public now, which is why I can talk about it. The first trial was, I think, 3 years ago, and we are seeing very positive results. That's why we use cows, because the size of a cow heart is about the same size as an adult human heart.
Makes sense.
And these cows have no heart. No, well, they're using miniature cows. They're small. I mean, not dwarf, but like they're the breed they're using are not like huge Herefords or Longhorns. Yeah, these are a very small breed of cow that have the heart of the same size. Here's the really remarkable thing that really freaks me out that we've redefined with this particular protocol: the definition of death.
Oh gosh.
This is what gets me excited for anatomy, guys. This. So the definition of death has always been you have no heart rate, right? You have no pulse, you have no consciousness, right? No heartbeat, no pulse, no consciousness. We've now redefined all of that because these cows are just standing there, because it is an awake surgery, meaning we recover them, and then we keep them alive for what we call a 90-day plus or minus 10, meaning that we are trying to keep them alive for at least 90 days, but if we go plus or minus 10 on either side, we consider it a win. And they're just standing there. They're mooing, and they're eating, and they're pooping. They have no heartbeat because there is no pump action. We can't figure out how to do this. We can't figure out how to mimic this pump of the heart. So what we have is it's a motor that does kind of like a water wheel, constant motor whir. And so instead of, if you put your stethoscope up to this cow, instead of love dub, love dub, love dub, love dub, you hear something that sounds like and no pulse. Because when you feel your pulse, it is so this is how, these are the top cranial chambers, the atria, ventricles are the caudal chambers, and your heart pumps like this, right? It's when these ventricles sploosh out the blood into your arteries and your blood vessels that you feel your blood vessel push against your finger. I don't have this, do I? So there's no pulse.
Kind of
So
freaky.
we are making biomechanical beings.
I mean, imagine the people that could help.
Well, we will no longer have to depend on donors,
Exactly.
rejection.
Anti-rejection meds.
What is what, sweetheart? So what a pacemaker does is you have a very specialized bundle of cells in your heart. See this, you guys are getting interested, I like it. In your heart, we have a very specialized bundle of cells. That's why I find the heart really fascinating. This bundle of cells creates and transmits its own electrical impulse. We don't know how it does it. We don't know why it does it. It doesn't seem to have anything to do with, like, it's not like my brain is transmitting the nerve impulses. It is just this group of cells manufacturing out of thin air, seemingly, their own electrical impulse. It is that electrical impulse that diffuses across the heart muscle and causes it to contract. That is known as the pacemaker. Well, what happens if that bundle of cells stops producing electricity? I have nothing to make the muscle cells contract. My heart is no longer beating. So what they do is they implant an electrical circuit, a mechanical pacemaker, that then mimics and sends that electrical conduction to cause those muscle fibers to contract.
Because my grandpa, he's done several different like procedures, but he just did the last one like a couple weeks ago, and they said that it would work.
Yeah. So what that is,
Wondering, like, what are the things that are-
so what it is it's just a mechanical that's sending an electrical impulse that causes the muscle cells to contract. So yeah, cardiovascular, super interesting. Respiratory. You can't talk about the heart without also talking about the lungs. The heart is the pump that moves blood throughout the body. The lungs are what are taking out the toxins, carbon dioxide, putting in oxygen into the cells for transport around the body. Without oxygen, you die. And it is these lungs that are converting the gases. They're your little red blood cells, your erythrocytes, are like little 18-wheeler tanker trucks, right? That's all they do. They transport stuff around your body. That's it. And so what they do is these little trucks, they're coming in convoy to the lungs, and they all have a shipment of carbon dioxide that your cells gave them. It's like trash day. They went and picked up the trash. They drop off the trash at the lungs, and then they pick up a shipment of oxygen. The heart then sends them on their way. They go to every single solitary cell in your body. They drop off the shipment of oxygen. They pick up the trash. They turn and burn, go back to the lungs. So that's the whole point behind the respiratory tract, to make sure that you have this oxygenation. The digestive system. Oh, another one of my favorites. Well, being a nutritionalist, of course, I love the digestive system. The digestive system ultimately their job is to disassemble stuff. So when you eat Chipotle burrito, the chicken, the sour cream, the tortilla, the cheese, all of it is not in a form that your body can use. Your body has no idea. It's alien material. So let's take the chicken in that Chipotle burrito for a second. Chicken is a protein. Proteins are made up of building blocks called amino acids. So think for a minute that those amino acids are very similar to Legos. Right? I've got all these different kinds of Legos, different colors, different shapes, different sizes. And each one of these different Legos represents a different amino acid. What can I build with Legos? I can build anything with Legos. That's kind of the whole point. If I have a high quality protein, meaning it has a lot of different kinds of Legos, versus a low quality where there might only be one or two different kinds of Legos. The more different kinds of Legos I have, the better off I am. How do I get these Legos disassembled? Because what I need to do in order to use the Legos is they have to be only a single Lego. If they're attached to another Lego, can't use them. So what my digestive system does is I eat the chicken, and it's a chicken Lego set. But what my digestive system does is it pulls apart each individual Lego, because that's the only way I can use them. It then puts those Legos into my blood, and those Legos travel to my liver. Your liver is very similar to a bank, right? If you, in non-pandemic land, wanted to travel to a different country, and all you have is American money, what do you have to do? I've got to exchange it. I've got to convert it. Well, those amino acids and those proteins and those carbohydrates, those are not the currency your body accepts. And your body is very, very greedy. Everybody gets paid. If it's not getting paid, it stops working. Kind of like you. If you showed up for your job tonight and they were like, hey, thanks for coming in. We realize we can't pay you today. So we're going to need you to work today, but we're not going to give you anything in exchange. Sorry, bye. Same thing with your body. Everyone got to get paid. But the currency that you're taking in that food is not currency your body will accept. And so once we have disassembled all of the Legos, we need to convert them into something your body will take. The liver is what does that. It converts all of your nutrients into something called glucose. And then it takes that glucose and sends it out, and that's what nourishes and pays your cells. Or if you take in too much glucose, it goes to the storage unit so that you can use it for later. So that's basically your digestive system. It just disassembles the Legos, sends everything to your liver. And then, of course, you have the end part, the terminal part of your digestive system, which is your colon. And his job is to regulate water and have a storage unit for all of the stuff that you couldn't use. So the undigestible remains of your meal, it goes to your colon, and then you poop it out. Your muscular system, we have 3 different types of muscles. You have your skeletal muscles. These are muscles that are attached to your skeleton. and they are what actively move your body. They are known as voluntary muscles. We have our cardiac muscle, which is a specialized bundle of cells, which is only found in the heart. And we have our smooth muscle, which is what your organs are made of. Like this digestive system we just talked about. They do also have a muscle contraction, but it's a little bit of a different contraction. Instead of contracting towards the center, like my muscles here, my smooth muscles do kind of a circular, where they have like squeezing toothpaste out of a toothpaste tube, called peristalsis. And that's what moves stuff through this circular muscle. And smooth muscle, you cannot choose to move it, right? It's involuntary. Your brain and your body takes care of that. Your sensory organs, these are gonna be your eyes, your nose, your ears, etc., all, and your extrasensory organ. We do all have ESP. Extrasensory perception. Now, am I saying you're psychic? No, of course not. However, we do have an old remnant from evolution that allows us to be able to feel when something is watching us. If you ever been in your car and your song comes on and it is your jam, and you've been having a great day and you are just belting it out. You are on stage, you are a rock star, the crowd is going wild. And suddenly, you get that little do-do-do on the back of your neck, and you stop singing and you look over, and the entire car of people next to you is looking at you,
Laughing.
How did you know? Those of you that have kids, those of you that are moms,
Yes.
you've experienced this. You're sound asleep. It's the middle of the night.
And your 2-year-old standing right.
And your
next to
2-year-old is standing there staring at you, and you just, whoa, God!
Tell me why my daughter does that all the time.
My son does too.
I-
Why are you
Oh my goodness.
He's asleep too.
And it's terrifying. Because they are not making a sound. It's not like they woke you up because it was a sound. Your brain has this extrasensory perception that something is watching. I know, it's terrifying. I'm so happy I've never had children.
It's just funny because my daughter did it to us the other night.
Yeah, my
dogs do it.
sister, so when I was a little itty bitty little thing, my middle sister, who's 2 years younger than me, she would do that all the time. And she'd go and stand and just stare at my mom and dad. And they would wake up and just like wet the bed. Right? It's terrifying. It's terrifying.
It is.
If you've never woken up with somebody just staring at you, it's terrifying. Terrifying.
What triggers you to just know to do that? Like primitive.
It's that primitive extrasensory perception. It's just something left over from evolution. Kind of like if you're a hunter and you see the deer and you've not made a sound and the deer suddenly looks up and runs away. It's that extrasensory perception. The endocrine system, your entire body is governed by hormones. Now, when I say the word hormone, the first thing you guys think of is teenagers, estrogen, progesterone, testosterone. We have so many other hormones. We have hormones that govern your stress. What was the hormone we talked about that was your stress hormone? Cortisol. But you also have hormones that govern your moods and make you feel nice, like dopamine, melatonin. You have hormones that govern the color of your skin, melanin. You have hormones that affect your nervous system, adrenaline. You have hormones that help take down any kind of inflammation and damage, like your naturally occurring steroids, like cortisol. You have corticosteroids. So all of these hormones from different glands are governing everything about your body. The urinary system, these are gonna be your kidneys. Medical term for kidney, remind me, I just told you that earlier in this. Nephro or renal. Your ureters, which is the tube that takes pee from your kidneys to your bladder. The bladder is just a holding pen. Its medical term is cysto. And then you have your urethra. And the length of the urethra will vary varied on sex and breed and species. And then finally our reproductive. Males have testicles, scrotum, and a penis. I'm not telling you any new information right now. You should not be shocked by this. Girls have ovaries, uterus. Now, the reproductive system of our dogs and cats, ultimately the exact same as humans, except the location and the function is a little tiny bit different. Just kind of an interesting. So let's take our female canines, right? It's called a bitch. Get the giggles out now. The medical term for a female canine is a bitch. And we will be using the appropriate medical terminology. So I'd rather we get the giggles. Oh my God, she said a bad word.
Is it the name of them or only when they're in heat?
No, any female is a bitch. So males are known as dogs. Females are bitches.
So rude.
Well,
I'm sorry, on that. human
for us,
perspective.
they're just calling you a female dog,
Yeah.
which there are worse things to be.
Yeah.
That's
true.
Like a female cat is known as a queen.
Aw.
Yes. A male cat is called a tom.
So,
It's just the term dog means male. So female dog. Here's my ovaries. Here's my little fallopian tube. That's what moves the eggs. Humans have a very large uterine body and very short uterine horns. And that's because we're only meant to have one baby. Dogs and cats, they have all the same parts, except they have very long uterine horns and a very short uterine body, because they are meant to have multiple babies. When we do a hysterectomy, uterus, ectomy, removal of. So if I do an ovarial hysterectomy, I'm removing all of this. Yes.
Can that one vary on the breed of dogs?
It can. Depending on what size litter they are genetically supposed to be having.
And is it all the same for humans?
Pretty much, yeah.
Cause like, like Octomom, she was trying to have one kid and she came out with like 8. Like,
That
that's
was-
terrifying.
Fertility treatment.
Yeah, that was not naturally
Oh,
done.
really?
Oh,
Oh,
yeah.
yeah.
She didn't look natural, but I was just like,
No.
Yeah, that was done for fertility.
I'm sure it was. She probably made it up with all her TV shows, though.
What's it called? My husband.
Huh?
My husband had.
I'm gonna pass these down because you guys get items back.
Lord, no.
And Great Barrier Reef are huge, so these.
All right, so we are gonna pick it up here on tomorrow. And tomorrow we are gonna start talking about anatomical planes. You need one more? We're gonna talk about anatomical planes and directions. We're gonna start doing a bit of interpretive dance. Put your dance shoes on. Oh, well, it's okay, you'll need them tomorrow, so bring them tomorrow. All right, so you guys in TV land, you guys can go ahead and sign off. You guys here, I'm gonna take these guys down and get their books so that they'll have them. So for you guys in TV land, I will see you all tomorrow.
Is it
Thank
okay if I
you.
use for this?
Of course.
Or can we use pencil on this?
No, please
Okay.
use pen.
I didn't bring a pen with me. That's not it.
Everyone.
That's
So give me just 1 second and I will explain.
she needs a form.